Greetings everyone, and thank you for tuning into this video. I'm going to speak today about a project called the Coolum Beach Christian College. It's a school that my team at ARGO Architects and I designed about 20 years ago, and we've been building for 15 years beyond that. We're now in April 2020, mid-coronavirus pandemic. To give you some perspective of where we're at. So we're able to look back at the completed project, or the mainly completed project now, with some perspective. What's significant about this project is that Coolum Beach Christian College, located on the Sunshine Coast in Queensland, Australia, is in a beautiful environment, really one of the most glorious sites. The things that I'm going to talk to you about are the environmental sustainability issues. And this started right at the outset when we selected the site, and we were well aware that the only service we had to the site was power. There wasn't telephone connections, there weren't sewage or water supply, stormwater. All of these things had to be managed in an autonomous sense. So when we talk about environmental sustainability as architects, we're looking at how we can minimise ongoing operational costs in the first instance. But we're also looking carefully at construction costs. There's usually a payoff that you pay more in the capital costs for sustainable design, and then you accrue it in the future. You amortise that extra cost by having lower operational costs. That used to be true. It's not true anymore. It's now possible to do sustainable design without spending more money than a non-sustainable project. And I'll try and explain this as we go along. My name is Will Marcus, and my team and I realised this project over a series of 15 years. We started with a bare site, and in the first year we had 20 children in grade 1 housed, operating, and each year we built year on year as these children progressed through grades 1, 2, 3, 4, 5, right through to 12. At this point in time, there are 350 children on site, plus staff. The site itself will take as many as 1,200 pupils when it is fully developed. Now, sustainability in a school is an important aspect for several reasons. The main one in many people's eyes, certainly in the bursar's eyes, are that if you build in sustainability, means your ongoing operational costs will be lower. Things like not having to paint the school every 5 years, not having a power bill, not having a water bill. These matter. Operational outgoings are a big deal for schools. They are large pieces of infrastructure usually. And if these can be counted at the outset and it's done properly, then that legacy lasts for the life of the school. And it could be 60 years or more, depending on how well the school is built. And so making important decisions like this early on impact the future in a very serious way. I'm going to try and order this in some way so that you can understand that there are different parts of sustainability that need to be considered. In the first instance, we're looking at the landscape architecture, the topography, sunrise, sunset, breezes, viewpoints. And what's important about looking at the landscape, and unfortunately this is rarely done at the outset, it's always the thing you do when you finish the building and you just tidy up the landscape. If it's done properly, if the planning is done properly at the outset for the landscape architecture, it can aid and abet sustainable outcomes more than people know. For example, if you plant a forest on the western side of a classroom block, then it won't receive setting sun, and the extra thermal gain that will prevent on the building is very measurable in terms of dollars associated with air conditioning costs. Similarly, if you plant appropriate landscape on the windward side of a building, as the breezes come through from that direction through a small forest or a heavy landscape, it filters the air and it cools it, as well as gets the humidity just right for humans, and then allows it into the classroom and then through the classroom and out the other side. And doing this can make some significant changes to the air temperature, notwithstanding those actual physical examples of how landscape operates. The whole benefit of having the water cycle operating in and around classrooms is tremendous. And with all of these things together, we can knock somewhere between 4.5 and 19 degrees Celsius off the temperature of daytime air. And of course, this will go towards making the learning environment much more comfortable and naturally cheaper to operate. What do I mean by water cycle? I think it's important to understand that there's a very well-known but not well appreciated function in a landscape, and we've all learnt it in grades 4 or 5, where plants and trees transpire moisture through their leaves in the daylight, and then at night the trees, the moisture that's been transpired comes back into the landscape as dew irrigating the landscape. We've never really appreciated it until recently, and I'm saying recently, the last 8 years. The amount of water that lands in dew is so significant that it can fully irrigate a landscape if you know what you're doing with the landscape design. And likewise, landscapes can self-fertilize. So I guess this falls back to the actual layout and design of the landscape, but why I'm mentioning this now is that if you get a good functioning landscape occurring around your buildings, you'll modify the climate so significantly that it makes life for humans much better. Don't always get an opportunity to deal with much landscape around schools. There's a lot of concrete and bitumen everywhere. And our approach to that is to rip up all the concrete and bitumen and plant a forest instead. Of course, children have to get around and there have to be places to play. But if you design your paths and your access ways and your play areas precisely and concisely, then you end up liberating a lot of area for landscape. Now, a lot of people think that landscape is more expensive than concrete or bitumen, and that is just not true. It's much cheaper to plant landscape, and it's much cheaper to maintain because it doesn't need sweeping and cleaning and repairing. Landscape looks after itself, and anyone who's been in a national park lately would, or any time in their life for that matter, would realise just how easy landscapes are. Humans don't get involved, particularly in natural landscapes. If there's no human intervention, they look after themselves forever. And landscapes in schools can be designed in this way. The beauty of this is the natural forces that create landscapes and keep them operating with a fractal geometry, and that's just a fancy way of saying that it'll happen on a very small scale. So you could do courtyards that are fully functional and self-operating, or you can do it on bigger areas, much bigger areas, whole schools, hectares and hectares. In fact, whole landscapes obviously will function that way because the geometry of the landscape function is fractal. It opens up and keeps helping itself to its own nutrients and to its own moisture if you know what you're doing. So another important part of landscape function is that it minimises the heat bubble that most schools would have. In fact, this is common around most cities, and it has to do with a lack of biomass. So the more biomass you can have on a site, the cooler the site will become. The heat bubble is something that's hard to remove once you've got one because it actually chases moisture away. Natural law of science is that moisture in the air, whether it be rain or dew or mist, water vapour generally, will always move towards the cooler gradient. And that means that if you have a heat bubble around your school, it'll chase away any moisture that might be in the vicinity. So it's kind of beholden on us as planners and architects and landscape architects to cool down the school environment so it attracts more cool air. And in doing so, you create a better environment for everyone. Now, the second part of sustainable design, let's say, is the building itself or buildings. And so with the Coolum Beach Christian College, we were very particular about controlling temperature and breezes and humidity naturally in the buildings. And the way we went about this was we had several approaches, but mainly we were looking at the prevailing breezes coming from the northeast, north to northeast, and some from the southeast. And as a result of that, because about 80% of our breezes were coming from the north to northeast, we always placed a native forest on that side of the building so that the breezes had to come in through the forest, so the air got filtered, naturally cooled because of the transpiration off the leaves, and the humidity was also affected as the temperature of the air naturally dropped. So we brought in naturally filtered, cooled and dehumidified air through into the buildings, and we allowed it out the other side. Now, the way we set that up in the buildings is that On the approach side, we had very large sliding glass doors which opened out onto verandas. And on the lee side, where the air was leaving the classrooms, we set up huge louver banks. So we could throttle the amount of air that we wanted to come through. So there wasn't ever a situation where air wasn't moving and you weren't blowing papers off desks. It could be controlled naturally by the children. And so once everyone was taught how to do this, it became a link to the environment that all children and all teachers understood and could practice and do it very well. So the throttling or the controlling of breezes became something that they all naturally did and understood from day one. Another primary thing we did with the buildings was to elevate them off the landscape. So the buildings are sitting up in the air. We did this for a variety of reasons, but mainly it gets us to a point where all the views out of the classrooms are into canopies, palm tree tops, so straight into the foliage. We're not looking at the dirt or the ground. And it also separated the children from the general activity outside. And so this is also part of controlling views. Children, when they're sitting at their desks, weren't able to be distracted by children playing on the oval or outside in any area. They all, though, had excellent views of vegetation and the sky. And this proved to be a great bonus to teaching generally. On the cross-ventilation aspect, in the classrooms is not only for control of the quality of the air, but there is a soft science about the relationship of plants, trees and humans. It has been well considered over the last 40 years, and there are many papers written on the relationship between humans and plants. And it comes down to a volatile organic material that comes off the leaves through the daytime. It's called a VOM, a volatile organic material, and it's like a light oil. It floats around off the tree. It emanates off the plant leaves. And there's a quantum relationship between these VOMs and the plant, in that the VOMs report back to the plant about the environment in which it works. But over the years, scientists have started to understand that there's a relationship between VOMs and humans as well. And we intuitively know this. We're always attracted to leafy suburbs, for example, and we know as a fact that leafy suburbs are more valuable per square metre or square foot than suburbs that don't have a lot of vegetation or biomass. It also has to do with work productivity research. Offices with lots of plants in them, or say 4 appropriate plants per person inside an office, will have a work productivity of 30% more than an office without. This is a pretty serious outcome, and it bears a lot of investigation. There's a lot written on it about the psychological and physical effects that plants have. And even if we don't properly understand it, the outcome's always true. And so we work very hard to make sure that plants are a part of the life of a school. And so having a forest filtering air, picking up VOMs and feeding them through the classrooms, for us is a very important aspect of getting great learning outcomes. When we are designing the classrooms themselves, we worked very closely with the school board to make sure that we had an optimum outcome and an affordable one for them. We elected to use lightweight construction because it went up rapidly and it is in the main renewable, using timber stud frames, timber floor joists, bearers, etc. So the cost of the building went down, but the durability of the materials we used was very high. So instead of using the traditional brick construction, which is what a lot of schools are made of, the lightweight construction allowed us to build into the architecture things that didn't belong normally. If you think of a normal school made out of masonry, the windows are particularly large because they're an expensive part of the building, and the area for each classroom is restricted because the cost of construction is high. Going lightweight in our construction wins us money back into the budget because it goes up so rapidly. And in fact, it can often be done off-site and brought on site in modules and erected super quickly. So the benefit of this is that we could then use as much window wall as we liked. We could use expensive window types like louvers, which allow us to control breeze, and big glass sliding doors, which gave us the ability to open up whole walls. So with that sort of freedom to spend a bit more money in other areas, we also looked at the cladding, and it was important for us to keep the buildings human And although it was tempting to use a lot of steel work, steel like roof sheeting, colour bonded or zinc aluminum sheeting on the walls, we also used a lot of raw hardwoods. We used hardwoods in screening in balconies and bridges between the buildings. There's often a bit of a complaint about the maintenance on timber in buildings, but that is only the case if you don't know what you're doing with species selection and detailing. We've got the luxury of looking back over 20 years of timber work on this site, and we know that with the correct selection of species, the right milling of it and the use of the right size members and the correct coating, we used natural oil on the timbers to protect them. There has been almost no maintenance on the timbers on this project, to everyone's surprise. That was one of the hardest things for us to convince our client that this was not going to be a problem for them in the future. The other aspect was that we had enough money to create huge amounts of insulation so we could protect our eastern and western walls, which is the rising sun and the setting sun, from too much thermal gain by insulating those walls heavily and not fenestrating them, so no windows in those walls. We're able to reject a lot of thermal gain that a lot of classrooms just don't even think about. So all our openings, our windows were on the north and the south. And of course, because of the nature of our prevailing breezes, that allowed the breezes to move through the buildings very, very easily. So we presented to the setting sun the smallest possible wall space that we could. So our buildings generally on site were 2 long and 1 wide, and the 1 wide was the face that we pointed towards the setting sun and the rising sun. Now, the insulation is important because you don't want the heat that does get onto these walls to get through into the building. And contrary-wise, if it's very cold outside, you want to be able to maintain any heat that you do have inside the buildings without losing it rapidly. Another important design factor, and arguably the most innovative and successful solution architecturally, was that we did a double roof, or what's called a fly roof. If anyone's been camping, you know that when you put your tent up, you can have a fly that goes over the top of the tent, which protects the tent from moisture or direct sunlight, and that really modifies the climate inside your tent. We took that principle and we applied it to the buildings. If you can imagine the classrooms being a standard building, and then we built another roof on top. And what that did was that it allowed a space of air, normally about 0.5 metre, 600 millimetres deep, and because the roofs were tilted, they had a slope on them, we had moving air between the 2 roofs would come in from the lower edge and rise up and out the top. And it would do this because the sunlight landing directly on the sloping roof would superheat the roof and then it would convect through the roof and create convection. And of course, hot air rises, so it naturally piped its way out and out the top end. And so by trapping and dealing with the heat of the sun in this way, we created, and we measured this, 4.5 degrees Celsius less heat inside the classroom than a similar building with no fly roof. Now that's a huge energy saving straight off in air conditioning. And what we discovered was that on average, these classrooms would use the split air conditioning systems we had inside them as backup only 2 weeks in a school year. Needless to say, that cost saving is significant, and because it's ongoing, incredibly important. Other really important aspects of the passive design in the architecture were the roof overhangs. So we collected very large overhangs where we needed them to shade the walls of the building, certainly the windows. We never wanted direct sunlight to come into the classrooms. We always just wanted ambient light coming in. And that, of course, has everything to do with, again, thermal gain and comfort inside the rooms. So the overhangs were designed always to protect the walls, and we use them quite effectively to act as covered ways. So even though these are outside the buildings, this is where we would put bridge connections and paths so the children could move around the school without getting wet when it's raining. With regards to lighting and all electrical, we elected to design the buildings so that they would allow the retrofit of photovoltaic cells on the roof for collecting sunlight and turning it into electricity. And though that didn't start for the first few years, eventually the school got funds together to buy photovoltaics for all the roofs. And now, at this stage, there's 36 kilowatts of unit on all the roofs. And the importance of this is that that's enough energy going in through sunlight to offset any power consumption that the school needs, so they have a net zero cost on electricity. Now, the school is connected to the grid, and so what happens is that the sunlight on sunny days is coming into the system and charging up and being fed back into the grid. So effectively, the meters on the power system into the school run backwards, and the school goes into credit with electricity. And as it draws it down through the day, or when they're air conditioning, or at night when there's usage, it draws it back out of the grid and uses up the credit. And so the amount of photovoltaic array on the roof is calculated to offset the energy consumption. And as the school expands, this will be maintained. More roof, more power consumption, more photovoltaics. Now, it's important to understand that even though the photovoltaics have a cost, and this is traditionally above the cost of a school, in its own right, its own business plan. So the cost of the units is amortized over a period less than the replacement period of the units themselves. And that allows the school to justify the initial capital cost. Now, the final part of passive design with the architecture is that we are looking at all the materials very closely for their toxicity. Of course, in a school environment, it's important, particularly with small children, that nothing is toxic. And now we're a long way from using asbestos and lead-based paints, which was the case historically. With this school, even 20 years ago, we were looking for no volatile organic fumes coming off any of the plastics or the chemicals that we use to coat materials. And so there are a lot of carpets and paints that have VOCs there's the acronym for it. But you have to seek them out and use them correctly. So there are a lot of cement-based paints, and some materials just don't need finishing. For example, all the hardwood that we used in the decks and the floors and the screens and the balustrades is raw. And apart from the oil coat that it got in year one, it doesn't need more than another oil coat every 5 to 10 years to keep it in very good condition. And we know from plenty of examples that timber in this way, selected correctly and treated in this way, will last up to 1,000 years. Plenty of examples in Germany and Central Europe that show this. And if you ever want to look at a jetty made out of timber, a lot of them are 100, 150 years old. Timber lasts. You just have to know what you're doing with the selections and the detailing. With the external cladding, we use a lot of pre-finished metal sheet, corrugated iron, if you like, custom orb as it's better known, and mini orb. These metal sheets have several finishes, but Coolum is a common one found in Queensland a lot, which is just a protective coating that's electroplated onto the sheet normally. And the other one is Coolum, which is a baked-on paint finish that has a very long lifespan. Now, this particular college is not on the coast, but close to the coast. And so the coastal air is full of salts and is more corrosive than general areas. So it's important that whenever we use metal in areas like this, you use the right grade metals and protective coatings. And of course, we did this here. So after 20 years, and we did an inspection recently, there was nothing that had been done to the outside of the buildings, and I mean nothing. They were in perfect condition. They could possibly have had a little bit of a clean, but it wasn't essential. Some spiders have decided to make homes in some places, but not chronically, because the native environment encouraged birds, which like to eat spiders. And so there was a balance with all of this on site. But what that means is, for the school, is that they don't have to paint regularly the outside of buildings, which is very expensive to do, particularly if you have scaffolding every time. And in the state of Queensland, there's a law that says that schools must be painted every 5 years externally. Now, if you have no paint surfaces, then you eliminate that cost out of your ongoing budget. It's a very important and very large sum not to have to swallow every 5 years. I might make one statement about the lighting systems inside too. We went out of our way to use low energy lighting systems, LED where we could, some fluorescence. These systems were connected to PE controllers, which simply means that when the sky didn't provide enough sunlight, the lights would just turn on them by themselves. but they're also set up with motion controllers, or motion detectors, so that when a room was vacant, if the lights were left on, the lights would just turn themselves off automatically after 5 minutes. It's a huge saving, all in all, on a whole school. But the other thing we did with the lighting was that we arrayed the ceiling lights in banks. So the banks, as they approached a window, were less important than the banks that were in the middle of the classroom where the natural sunlight didn't penetrate. And so the teachers had the ability to manually override the system and turn lights on in the middle of the classroom, but not having to turn on the whole bank of ceiling lights became an important saving. Of course, it became very overcast in a storm outside, then all the lights would go on, but this generally wasn't necessary. So I'd like to summarise by going through the outcomes and of our sustainability program for this school. And I'll just go through point by point. We've ended up nominally with a net power bill of 0 or close to 0. And of course, as the school adapts, that will be maintained. There are no water costs other than the requirement to maintain and clean filters and sterilisation units, a minor cost by comparison to actually having to pay for water. We've got the free irrigation and fertilisation of the oval from sewage that's treated aerobically on site. And we don't have the attendant council fees for dealing with sewage from site either. There's a really important reduction in power consumption thanks to passive design in the architecture. The air conditioning is not required very much at all in any of the classrooms. And also because the lighting system is designed to be reactive to the environment and adaptive as the teachers need it, depending on daylight through the day. This also saves energy and considerable amounts. There's no repainting of the buildings outside, and as I said before, this is a really significant cost in Queensland because there's a law to repaint schools outside every 5 years. The inside of the classrooms have to be repainted, but the quality of the paints is always very high, and if the school commits to using cement-based products or low VOC emitting paints, then the environment will always be durable and also very safe for the children. The floors in the classrooms are all timber. They need very little maintenance. Because we use a water-based polyurethane on the floors that is dance floor grade, it will last 10 years before needing redoing. So that's a big saving on floor finishes. There's no carpets to be replaced. And so again, the ongoing saving is significant, and the natural timbers on the floor, of course, is a very durable and good-looking surface. And as I said before, the photovoltaic system pays for itself over a period, so it doesn't belong to the capital cost of the property per se. And I would suggest to you, or we know for a fact, that when each phase was built year on year, the cost of each phase cost no more than any other standard classroom, a general learning area, GLA or SLA, a special learning area, than any other equivalent building in the state of Queensland, certainly in the state of in the area of southeast Queensland. And because of this and the nature of the construction that we selected, we got a whole lot of benefits that schools can't normally have, which was pushed into the passive architectural aspect, which is important for the quality of the environment that the children are learning in. So I'd like to thank you for watching this presentation, and I hope that I've impressed on you how important it is to think carefully about sustainability in architecture in schools. The built environment's very important to get right, and not all buildings are born equal. And I would suggest to you that if you think carefully about your architecture and your planning, that you're going to make more than just savings, you're going to improve the lives of everyone in the school.